Phil Logan.
Peter Corbett.
Harmonix Turf Defence. This is true innovation. This is a completely new classification of product for fungal disease management. Yeah, let's get into it. We are a company born out of Bayer Environmental Science. We were divested by Bayer at the back end of last year, and we are now solely an environmental science business. And you may be familiar with some of the products that we manufacture and sell. Xterra stress guards. So we focus firmly on chemistry and pest management. Essentially, our sole purpose now as an environmental science company is advancing healthy environments for everyone, everywhere, through our chemistry background, but also new innovation solutions, which we're going to talk about today. So in the webinar, I'll go through very quickly because I don't want to take up too much time in this early part. Is we will talk about what biological controls are, because they are a new classification, and I think it's important that we define that and how they differ to biostimulants. Again, really important as we see more biocontrols come to the market. So we'll go over some expectations and what you can ultimately expect from a biological biocontrol. Then I'm going to introduce you to the product, Harmonix Turf Defence, which is an exciting part. Talk a little bit about some research at the STRI and an IPM. Then I'll hand over to Peter Corbett there from Origin, and he'll talk about synthetic pesticides and some Origin-specific research in an IPM using Harmonix Turf Defence alongside other products which are not from Envu. And then a summary. We'll do some CPD points for the bigger and ATPI guys that collect those, and a bit of time for questions, hopefully. So let's get cracking. Important point: what are biological controls, shortened to biocontrols, and why is it important to understand? Well, hopefully by the end of these next couple of slides, you'll see why that is. So let's just start off with a couple of definitions. Really, I think that's the most important part to start. And essentially, when we look at biological controls as a definition, they are the use of living organisms, in this case bacteria, to destroy. And I want you to focus on the word destroy, other organisms which are harmful to plants or crops. If it is a control or a reduction product, then ultimately it is destroying something else to protect the plant or crop. Their mechanism is to target a pest directly, whether that's a fungal pathogen or an insect or a weed. But that ultimately excludes biostimulation, and that's important. As more biocontrols come to the market, we can say this has control, this has reduction. Biostimulants work in a very different way. Not that I'm saying that's not important, but it's very important to understand that it is different, because ultimately that clear definition and understanding will facilitate efficient regulation and implementation going forward. It's important that we understand what our products do and apply them at the right times for the right pests, which is why we need these clear definitions. Biostimulants, well, up until recently, biostimulants are a very murky world in terms of what actually is a biostimulant, but there are new definitions coming through, and there will be some legislation that reflects that definition. But ultimately, if we look at the newest definition, a plant biostimulant contains substances or microorganisms, so it can be natural, but ultimately they can't have a direct effect on a pathogen or a pest. They have to stimulate something within the plant. It has to be independent of nutrient, so it can't be nitrogen that's stimulating natural plant processes. It has to be something independent from that, and it will have to be proven to affect one of the following characteristics. So nutrient use efficiency, important. Tolerance to environmental stress, again, important. Quality traits and availability of nutrients in the soil or rhizosphere. But ultimately, what I want to get to the point is biostimulants are not used to control, reduce, or destroy pests. We look at just biocontrols on one side and biostimulants on the other side, and we'll look at a few categories which are important to understand. Definitions, well, we've gone through that, so I'm not going to touch on that. But mode of action, how do the products actually work and what they do? Hopefully you got to the point that yes, they target a specific pest or pathogen. Biostimulants, on the other hand, will they enhance plant metabolism or physiological functions? Pest management, how do we use them to control pests? Well, they control pests by perhaps inhibiting growth, reproduction, or causing direct mortality. If that is the case and we make some claims, we must register those products as plant protection products with a MAP number, and everything that comes associated with that in terms of environmental impact. Biostimulants, on the other hand, focus more on enhancing plant health, resilience, and overall performance. Not that that's not important, but it is different. Environmental impact, well, both of them tick some pretty good environmental boxes. They're generally both considered environmentally friendly. They have low toxicity and non-target toxicity, and they do not persist for very long in the environment. So they, once you've sprayed them, they won't last as long as perhaps synthetic molecules. Application, generally applied. Well, certainly with a biocontrol, you must apply that where the target is. Biostimulants generally will be active somewhere within, whether it may be seed or within the root. Target, well, again, hopefully you got to the point that the target for a biocontrol is the specific pest, pathogen, insect, fungi, nematodes, whatever it may be. With biostimulation, there is no direct action against pets. Rather, promote growth, root development, nutrient uptake, stress tolerance. Some examples just in the industry that we have: Bacillus amyloidofaciens, that does exhibit certain fungicidal properties. Or a really recent one is pest parasitic nematodes that are parasitic to tipulas, to leather jacket larvae. That has been used in recent times as a biocontrol to those insects. Biostimulation, I'm not going to go into them. There's a lot of examples, and I'm sure every single person in this call will be able to identify one or more products that has those in them. Different, not less important. So that's the definitions. Hopefully you can see I've made a good point on that. Now it's time to really sort of dig into biocontrols as a general idea. What can we expect from those products and some of the facts? Well, efficacy of biocontrols, it will be. It should be no surprise that it's generally lower than synthetic pesticides for a number of reasons, which you should understand by the end of this presentation. But if we look at synthetics, so our synthetic fungicides, we generally expect 80 to 90% efficacy when we look at them against untreated controls when used alone. Okay, so nothing else in that integrated plan, just synthetics. So that's, if your control was, if your untreated was 100, you would expect your synthetics to achieve around 20 to 10% disease in those. Biocontrols, on the other hand, well, that it will depend on a lot of things, but 60 to 65% effective when used against an untreated control and when used alone. Another important part to remember. As turf managers, we do not just rely on one product anymore. Those days are long gone. So just bear that in mind as we go through the presentation, that this is just an additional part of an integrated pest management or integrated disease management program, which can add to it. They're less persistent because they're found in nature, so they're obviously going to be less persistent. Biology is much quicker to break them down, so they don't last as long, which is good and bad at the and has. It's not just it's bad. It's good at the same time, but it has a few points to make sure we understand. So we have to manage those expectations. Using biocontrols alone is important, but they cannot do what synthetics can, and we have to understand that when we do use them, we have to understand what to expect. But your goals will vary depending on your facility, and you'll be able to find exactly how that might suit. There's little or no residue. They're natural. They're found in nature. So as soon as we reintroduce them, soil biology can easily break them down. So environmentally, they are sort of fantastic. Okay, very likely to find these anywhere you don't want them. They're a good resistance breaker, which we'll come on to later when we look at the new groups or the current groups of fungicides. But biologicals, resistance is less likely. Research is limited, but they are multi-site, meaning pathogen resistance is challenging. The pathogens can't learn it particularly easily. Ultimately, we've got some research to show that biocontrols can be used to reduce our synthetic chemical usage, helping as an industry to become less reliant on synthetics, although not to stop using them, and overall to use less of them, which is a good thing. They're a great innovative tool to introduce into an integrated pest management strategy for preventative disease control. And I think it's fair to point this out in this presentation that they are a lower cost than conventional fungicides, around half. We're very happy to share that with you. So that leads me to introduce you finally to the new product, Harmonix Turf Defense. Okay, it is ultimately the first registered biocontrol fungicide for the control of disease and management of turf in the UK and Ireland, available this year through Origin and Crop Care in Ireland. What is the product? Well, hopefully it's no surprise that it's a natural biocontrol turf fungicide. Okay, I think I might have made that point. Some interesting facts about it. It's a unique patented strain of Bacillus amyloidofaciens. It was discovered in a peach orchard in 1995. So that's how far the strain goes back. The bacillus itself, the bacteria itself, we take that in and we put our research and development behind it. We boost that bacteria through formulation and through production. So for Harmonix Turf Defense, we take turf-specific formulation, boost it with adjuvants and wetting agents to improve its efficacy, which is important when it comes to biocontrol. Considering where we are with the sort of 60 to 65% efficacy number. If you look at what formulation can do, if we take this table over here, we have this is a barley leaf, for example, and we have the water droplet. So this is a tap water. This is a horticultural bacillus formulation, and this was the initial turf prototype. And this is what was agreed upon with Harmonix Turf Defense. So you can see very good spreaders in the formulation, which is key, particularly with Harmonix Turf Defense, which is not mobile within the plant. So coverage across the canopy, which is challenging in turf when you have so much plant material, is absolutely key. We actually found that we were able to add up to 20% efficacy by just formulation tweaks. Ultimately, it's a vital tool in an effective IPM program, and as I've touched on, it can result in reduced total volume of synthetic pesticides and providing similar levels of control when used in an IPM. Mode of action, the real interesting stuff. Okay, how does it actually work? What does it do? Yes, it's a bacillus, but what does that bacillus bacteria do? Well, it's three. There's three mode of actions. Okay, it's a multi-site fungicide, of which pretty rare these days in turf. First point is it has direct action, antibiosis. Okay, this is through a production of a natural chemical substance called lipopeptides. This is not actually the bacillus. These are what the bacillus make in the fermenter called lipopeptides. Lipopeptides have fungicidal and bactericidal properties. There's a second mode of action, active on the pathogen and the plant and through the roots, is the fact that some of the properties of bacillus switch on plants' natural defenses. So it's able to fend off disease and make it harder for disease to develop. And thirdly, bacillus itself, so this is the actual bacteria, can create symbiotic relationships in the root zone and around the roots, which first of all creates a physical barrier and is also acts as competition for nutrients, again making it harder for disease to develop and grow, with a few other benefits as well. So multi-site fungicide, let's just look at this mode of action a little bit more detail. So as I've touched on, it has been reclassified. Subtilis has been reclassified. The strain used was a strain QST 713. We found that strain produced a huge amount of lipopeptides, fungicidal lipopeptides, during the fermentation process. And there's three classifications that are particularly important to its fungicidal nature, in its contact fungicidal nature. So the first one is iterans, and you can see these here on botrytis. So once we've applied botrytis, the iterans essentially inhibit spore germination and they cause the spores to break apart. And I'll show that in a picture later on. Once we apply those, if they land on the fungal pathogen, it pierces a hole in the cell and it leaks out. Once they've gone green, that fungal cell is dead. The agrostatins themselves, this is the second classification. Well, they destroy growing mycelia. Again, very important if you have disease to use something that has some activity on growing mycelia. And these actually act and can destroy and break apart the mycelia chains. And there's surfactants within there which synergize to increase the membrane disruption. Let's not forget that there is actually bacillus in there, and that induces the natural defenses. And as I've touched on, that bacillus also, once it creates the relationships in the root zone, can create a protective biofilm and make it harder for disease to develop. Lipopeptides. The real driver of the product are the amount of lipopeptides that are made by QST713. Essentially, this is how we make lipopeptides. This is how lipopeptides are formed. We take our bacteria, we put it in a fermenter. This is a lab fermenter. Obviously, we have much larger ones when it comes to production. We add food source and we control those conditions over time. It's not a particularly long period of time, but we control those conditions very carefully. And that results in an exponential multiplication of the bacteria. And that is when lipopeptides are formed and when QST713 produces a large amount of them. As time goes on, the nutrients are fully consumed by the bacteria. The bacteria come into sort of storage form, and that results in 2-year storage. So from a biological perspective, that's great. 2-year storage in a standard ChemSafe. The product itself is simply just product and formulation. It's a liquid formulation. Just a point on bacillus themselves. There are thousands, millions of strains. We screened tens of thousands of strains to come up with Harmonix Turf Defense, but they are not all equal. When we screen our bacteria to see how fungicidal they will be, we profile the lipopeptides. Harmonix Turf Defense. The reason we settled on it was the huge amount of fungicidal lipopeptides made. Other strains, they do not. Some strains will produce more, but certainly some strains just do not. So ultimately, when it comes to bacillus, it is a minefield, and they're not all equal. So going with something that is actually proven fungicidal is important. And some bacillus will be used for other things, but this one in particular is fungicidal. A good way to think about lipopeptides in your head. If we take this is the fungal pathogen cell here. We see the nucleus, cell wall, and cell membrane. Once we apply Harmonix Turf Defense, again, lipopeptides are not alive. They are immobile. So formulation is key to make sure they land on the pathogen. Once they land on the pathogen, think of lipopeptides as billions of little nails. Once they reach a pathogen cell, they pierce a hole in the cell. The contents leak out, which ultimately leads to the death of the cell. So there's your contact action of this product, as well as the preventative of the bacteria itself. True multi-site fungicide. So as I've kind of touched on here. It is a patented strain, naturally occurring microbial. We use our expert turf formulation to make it even better. It works in contact with the disease. That's really important to understand, and with the plant's natural defenses. There's a low intrinsic risk to developing resistance because it's biological and multi-site, and it's very much a key tool in an integrated pest management program. Okay, so this is coming up to my last parts. I'll talk a little bit about application. So this is the kind of things you will see on the label. Remember, this is a registered fungicide. So this will come with a label, which again is very much the law and has to be followed. So we'll just talk about some of the things you will see. So in terms of applications, because again, fungicides are limited to how many times you can apply these. This can be applied 10 times per year, which is high. So that gives you an idea of how many times you can apply it. That's the maximum. You don't have to use 10, but that's the maximum for year-round use. But yeah, again, once the label comes out, you'll be able to see that. The timing, early curative. That means if you have disease, it can be applied at that point. You can expect a reduction, and preventative. So we would encourage a preventative approach, but also an early curative approach. It's an IPM tool. I think I've touched on that a few times now, to reduce overall disease incidence, but also to extend conventional fungicide intervals and reducing overall use. Maximum interval, 7 days. Rate 25 litres per hectare in normal water volumes. Rain fast in 3 hours. No need to add an adjuvant. And certainly no phytotoxicity observed well above 25 litres. Not that you would apply any more than 25 litres, but just to highlight that. It is tank mixable with Envu fungicides, and we're in the process of looking at other products such as biostimulants and nutrients. This is what the disease profile of Harmonix Turf Defense. So this is product only from registration trials. I'd like to highlight that those efficacy numbers are registration trials. We look at the product only. There's no nutrient. There's no iron. There's no dew dispersal. The maintenance is pretty lax. But those are the registered diseases alone. When we start to build in, and you'll see later on in the presentation, when we start to build in other people's products and other things and fungicides in the back and alongside it, we can really get that number up. And just to point out, other diseases are under investigation, including grey leaf spot and red thread. So yeah, we're very much at the early point of the Harmonix Turf Defence life. Unsurprisingly, I'm going to talk about integrating it into a program for disease prevention before I hand over to Peter, and he'll talk a bit more about origin-specific research. So this is when we start to get a hold of the product and put it into trials. We start to see some interesting things. Initially, I think the idea was that we use alone, but then what about when we start to build it into a program? And what's interesting about this trial is we have microdochium, and the microdochium in the untreated is the dotted line rising nicely. If we just focus on this frame, we can see that Harmonix here in the blue line had good performance, but this was every 7 days. Okay, good performance though. Well, every 7 days, a bit unrealistic from a practical sense. If we take the green line, if I just show you the green line here, this is synthetics. This is two fungicides, each of the green flags, day 0, day 28, or day 29. So did a good job. 5% disease, did what we would expect from synthetics. When we did the same thing on this kind of lower burgundy maroon line, we used the same fungicides, but we added some Harmonix in, and we got better control of disease. So that got us thinking how we can use this alongside synthetics to really bolster the program, and can we push sustainability to use less or space out our fungicides further to use less synthetics and use Harmonix instead. So we took that to the STRI. And this is an interesting graph, and I hope you can all follow this. But this is 2022-23 autumn disease trial, so microdochium patch at STRI. We have microdochium patch in the vertical axis, and we have the days across the horizontal, and I'll bring in the treatments as we go. So this is our untreated. We had a lovely amount of microdochium, getting up to almost 20%, just what we would like to see, a nice curve. Unsurprisingly, our red line, which was 3 applications of synthetic fungicides at day 0, 28, and 56, we saw exactly what we'd expect from synthetics, controlling disease nicely. When we brought Harmonix in at 14-day intervals, again, we got reduction, although not as good as synthetics. It's exactly what we say it does. But then we did something interesting. We took the same program. So this was the 3 synthetics, Exteris, and Dedicate, and we put Harmonix in between. We did the same thing in the blue line. But what we did was, on the blue line, our program finished, so Dedicate went on at day 56. That was our last application. So standard 28-day intervals with 14-day applications of Harmonix. Green line, we did the exact same thing, but we spaced it out further. So our synthetics, Exteris, Dedicate, went on at 35-day intervals, and our Harmonix went on at day 21. So essentially, what you can hypothesize from that is that 21 days after the Dedicate is when you're going to start to run out of protection. So around about here is when we would think we're getting under threat of disease attack. Whereas on the green line, this is when Dedicate, 21 days after. So if we saw a disease increase around here, which is not unusual to see 2 disease pressures in a year, we just didn't get it at the STRI on this year. It wouldn't have been unlikely to see the untreated shoot up around here. Perhaps not as high as 30, but bear with me. But if we think about that timing, well, that blue line perhaps would have gone up. And I appreciate I'm hypothesizing on this. But that green line, because we've still got Dedicate, well within the plant, it may have steadily stayed on. So that really is where we started to develop our ideas around this product as a sustainable product to reduce our synthetic usage, but also as an integrated product. And that leads me, I think, nicely onto the summary of that trial, which ultimately says that using Harmonix Turf Defence 21 days after a fungicide allowed application intervals of fungicide to be extended to 35 days from 28 days with no significant differences in disease. Using Harmonix Turf Defence in between fungicides and reduced disease more than fungicides alone. Harmonix Turf Defence will reduce disease when used alone, but caution caution is advised when disease pressure is high. That is unlikely to be acceptable. For best results, it should be used in an IPM that utilizes effective synthetic fungicides, overall reduced, and alongside non-pesticidal disease management program, such as biostimulant programs and good cultural practices, which nicely leads me on to Peter. Peter, I'll hand it over to you now. And thank you for that.
As we all know, plant protection products are under a huge amount of discussion and also, potential threat from legislation, arguments about sustainability in terms of what is more sustainable, etc. And certainly, obviously, there's a number of key things that are happening. Appreciate we've got people here who are obviously from Southern Ireland, so with the EU is an important part of obviously their legislation, whereas obviously in the UK we've got a slightly different situation now following Brexit. But as I'm sure most of you have seen, the EU sustainable use regulations are being upgraded. There is a discussion document that has gone out within Europe. Obviously this covers all areas, so crop areas as well as amenity areas. But if you look into the small print, there is an element in there which defines sensitive areas, and sensitive areas are basically areas that the general public have access to and are likely to be utilising. So it does mean that within the proposal, potentially all plant protection products within sensitive areas will no longer be allowed to be used. That has to be negotiated, and obviously, really, as we know, the EU takes a little while to go through all of its political processes and all the steps. So that is underway. In the UK, yes, the sustainable use regulations are being updated and being looked at, and obviously we're also waiting for the National Action Plan, which relates to use of plant protection products. But one thing that we do know is that because we're now running our own UK active substances list, and also alongside that the list in terms of registered products, in terms of registered formulations, labels and how to use them, and all products have now been given a 5-year extension if they were due to be coming up for renewal within 5 years from Brexit. So we do have a little bit longer within the UK, but also we have to appreciate that the scale of the market for amenity is quite small. So it may well be that some manufacturers may decide that if Europe disappears, actually what is the commercial benefit of supporting products, registrations, etc. within the UK. So it's always a challenge for us, but that's something that obviously as a business, that's where we're lobbying with those manufacturers to try and make sure that we can maintain as many products as possible to allow us to actually manage surfaces in the way that end users actually want them to be managed. So we do have a very limited number of actives as far as fungal control is concerned, and also a very limited number of modes of action. And I think the easiest way to sort of summarize that is if we actually look at the FRAC mode of action of that, and effectively there is a periodic table of all modes of action that are known, and they're all classified, and the active ingredients within those are also classified. So we can look at the different modes of action that we have available. We would call this group the triazoles in terms of as a group of chemistry that we understand about, and within that group you've got tebuconazole and difenoconazole. They're the only two triazoles that are actually registered within the UK and the EU at the moment for our surfaces. We then move into the next mode of action, which are group C2, and that's the carboxamides. That would be known as the STHIs in terms of the common parlance, and they actually act on microbial respiration. So they act in a different place within the cells, and therefore it's not possible. It's possible, but it's less likely that you're going to get an interaction and a crossover in terms of if any resistance develops. So we have in there flupiram and benzoflupiram, which are the two SDHIs which are registered for use on turf. We then move into C3. We would all call these the strobes. But if you look at actually where they physically work, they do work in a very similar place within the biochemistry of fungi, but actually they work in a different part of the pathway. So there is a possibility of a linked resistance, but so far that doesn't seem to be a major issue as far as turf disease is concerned. And then within that, we've actually got 3 active ingredients that are within that particular group. We then move on to the 4th group, which is the phenylpyrols, and this we would know as fludioxonil or medallion is the name of the commercial product. And again, this has a completely different mode of action in terms of it tends to work on osmotic pressure, and therefore actually effectively explodes cells in order to control them. And within the UK, that is the only 4 modes of action that we have registered at the moment. If you're in Southern Ireland, we have the phosphonate group, which is a PO7. They're registered, and that would be a product called Signature Extra, and that's Phosphotile AL. So its mode of action is quite complex, but it is classified as a host plant defense induction, and that effectively means that it encourages the plant to protect itself better. And then obviously now we actually have the 5th one that's available within UK, and this is classified as a BM, so a biological multi-site. And within multi-site, the benefit of this is that you've obviously got a much greater reduced risk of resistance, and the bacillus that we've been talking about fits within that group. So effectively, we either have 5 or 6, depending on which geography you're in, but it's still quite a limited number of modes of action. And also to help people looking at resistance management, the product labels will also contain what group these particular products come from, and those groups relate to the actual mode of action of the products. So, in an ideal world, you wouldn't want to be following individual groups, but also when we look at those, we don't recognize too many of those actives as individual products, because most of the things that we look at are actually formulated products. So in terms of commercial registrations, what we have is tebuconazole and trifloxy formulated together to become Dedicate, and then flupiram trifloxy to form Exteris, and fludioxonil difenconazole to bring in the medallion. So what do we actually have to play with in terms of baseline formulations? Well, we only have 9 formulations that are registered within the UK. There might be more names than that, because you can have identical formulations with different product names, but there are 9 baseline formulations in terms of synthetic, in terms of registered fungicides that we can play with. So what we all know is, unlike in the past, where we obviously had a pure curative product in terms of the available actives, we now have a limited option, and they are all basically preventative type products. So what we need to do is to actually look at how we can put those products into programs, because as Phil described, it's in terms of registering a product, all that you're interested in terms of getting a registration is actually what does the product do on its own, because you don't actually register a product. The data you provide is purely related to the individual product. So if we now get into the real world in terms of how we're actually utilizing fungicides, we are using them in preventative programs because we have to, and also we're obviously looking at them in combination with lots of other products. So we're very much looking at an integrated approach, and in this case we're going to be restricting it to autumn disease management. So what can we do in terms of an integrated approach to autumn disease management? And also, just as importantly, how can we actually how can we look at and see whether one program is better than another? Because whilst we've only got a limited number of options to play with, if you actually start including how long do I leave between programs, how many products do I put in a tank mix, actually you can get up to hundreds of thousands of different potential combinations of utilizing different products that are available. So whilst you're starting with a very simple one, it gets actually much more complicated when you want to compare it. And also what you want to be doing is comparing very much on a side-by-side basis. So you need to be able to have the facility to be able to literally compare products in effectively the same place. So you can put plots side by side because we know that actually, and even we've seen it within our own plot areas, is the previous history for that particular area makes a huge difference to the amount of disease pressure, etc. you're going to get. So it does mean to get real side-by-side statistically valuable data, you actually have got to have a lot of things under your control. And also the other thing we need to look at is spray intervals, and what can we use to determine spray intervals between the different programs that we've selected, and how can we make it so it is actually relevant to what we're doing and how we're putting programs together forward. What we're looking at within this series is using growth potential, because what we know from the synthetic fungicides and also from the nutritional programs is that actually the higher the growth potential on a daily basis or the cumulative basis over a given period, then actually the more often you need to go. So it is quite a good part of a model, and obviously growth potential is something that a lot of businesses, Origin included, are looking at. How can we build this into a disease prediction model? Because in an ideal world, we'd love to know that actually, given the conditions we've had for the last 7 days, what is the risk in terms of disease coming forward? So that's a lot of work that's ongoing. So growth potential, I'm not going to spend too much time on it, but it's quite easily defined. Obviously, it has come from initially looking at max min temperatures, cumulative temperatures, and for using for when you're timing nutrient applications. But it is also quite a good starting point to enhance the efficacy of not only conventional chemistry, but also biocontrols and also nutritional programs. There are limitations because the model isn't perfect, but what we have found is that certainly early on in the autumn, then actually the model works quite nicely in terms of determining how often you need to be applying. So if we just have a look very quickly at monthly data sets, so what we're looking for is obviously the growth potential on a given day. And as you can see from last September, actually, the growth potential for a number of days was very near to 1, but then it drops right the way down to half. And what you'll see is obviously the flow of growth potential is very different depending on the time of year. And certainly I think from ourselves, September, October, November, actually the GP gives you quite a good indication in terms of what spray intervals you need to go. So you're looking at a cumulative, and we're finding that 9.5 to 10.5 cumulative is as good a measure as you can get from the data that you use for growth potential. Moving into October, the GPs don't get anywhere near as high, but that's no surprise given how it's defined. But then also when you actually move to January, the GPs do drop right down, and certainly obviously for a disease that is cold weather, has already evolved to work in cold weather time in terms of microdochium, sometimes GP isn't quite good enough in that in that time of year. We now look, we're going to use GP for the timing intervals, so we've decided on that. We then have to decide on a number, how many days, cumulative days, do we want to look for? And so how are we going to actually start going about that? Well, we wanted to test the hypothesis that Harmonix turf defence was definitely something we could integrate into disease management programs. And what we thought we would want to compare is a number of things, so we could genuinely see what would the difference be between these products, and also to be able to run stats on it, so it isn't just a single plot, because we know full well, and actually you'll see a photograph in a second which is a great example, that previous history of what's happened on that site is critically important. And if you actually happen to position plots in different places, you're going to get different results. So we need to be able to run the stats on it. So what we decided, we would look at a full synthetic program. So that would be 6 applications of a synthetic using 9.5, or obviously because we're using GP, it could mean that we might want more, or it could mean we might want less, because that does give you some flexibility. But what we would then do is we would actually run alongside that a full synthetic program, but alternate with Harmonix turf defence. So every 9.5, we'd do a full synthetic, 9.5, we'd then do a Harmonix, etc. We would then look at, because the label application in terms of Harmonix turf defence, we would actually look at a fixed program with turf defence at a fortnightly interval. Because obviously we're getting the GP parts from these other ones, and there are only so many treatments that you can fit into a certain area. Obviously, as a business, Headland stroke OAS have had many years experience with and developments and tweaking the 2020-30 program. So we would use the 2020-30 plus mantle program, but we would alternate that with the turf defence, and we've also got the 2020-30 as well within the site. And then, out of interest, we would just look to see is if we did extend it an extra day, what impact would that have on the number of applications between 9.5 and 10.5. So that gives you the background of what we're trying to do. It's all very well having the background. It's very easy to come up with lots of different ideas, lots of different programs, but then you've actually be able to got to physically fit it in, because in order to make the trials actually worthwhile or statistically analyzable, what we do is we've used 2 by 1 meter plots, so you can see them here on the screen, but we also use a 20 centimeter guard. And actually, from a visual perspective, you can even see it on that picture, you effectively have got a huge number of untreated controls, which are the guard plots. It does mean that you're increasing pressure significantly on the plots, because quite often trials operators wouldn't necessarily have a guard plot in between. They would just have a slightly bigger plot and discount the edges. Then all of the programs will have 4 reps, and then we would do visual and digital analysis on top of that. So each of the plots, every time there's an assessment, will have 2 digital images which can be put through the analyzer to create a huge amount of data. The joy with the light box is, because it is a light box and it's a black box, no matter what time of day you do the analysis, then actually the light within the box is absolutely identical. So you can actually compare the digital images properly, whereas if you have the effect of sun, as you can see on this picture, it has a big impact in terms of how the digital analyzers can work on imagery. Very quick summary of the programs that we ran, and also in terms of how the 9.5 GPs worked out. So basically, by very early January, we actually consumed all 6 of our applications where we were using GP as a that. This is sort of information that the guys will have and certainly when they're talking about individual programs with you, they can talk you through the different options and the different ways that we can actually develop this package from the information that we've known so far. We definitely have got a lot to learn. We couldn't cover all the different options that we might have wanted to within the first year because physically we just didn't have enough space. If you actually go back to the original picture that I showed you, the bottom left-hand corner that you saw on the picture actually turned out to be a very low pressure area. Up on the top right-hand corner, because the trial site is split into quarters, that quarter was used for disease trials last year, and the disease pressure was phenomenally higher in that top right-hand quarter. So it does show you how important history is and how important it is if you are managing disease. If you let it go wild and let it go rampant, you've got a much harder job following on. So we're now going to have a look at those treatments that we did and follow them through up towards the end of March. So if we now look at the control treatment, and this is in that top right hand corner, which turned out to be the high pressure area, you can see by the time we actually got to early February, late January, we were up at around about the 50% disease level. And obviously, if you then looked at the guard plots in between the treatment plots, those were sort of similar, that there was a phenomenal amount of disease. Hence the pressure that all of the treatments are under in that area of the plot was important. And that's why we've actually analysed them separately, because if you just bang them together, you're actually going to get an average that doesn't really tell you an awful lot about what's really going on. So the 4 reps in the high pressure quarter have been looked at. So this is looking at the 20-20-30 with the mantle program and alternating on the 9.5. And if you consider what the pressure is here and what we've achieved down here, that is a phenomenal percentage in terms of control. And also, I think we know that certainly with 20-20-30, if you do come under big pressure, we would tend to enhance that program with a synthetic product as well as. If you're under low pressure, then maybe you don't need to enhance anything with the synthetic. If we now move on to the Harmonix fortnightly, so this is basically just using Harmonix on its own on a fortnightly basis. We then bring in the Harmonix alternated with a synthetic fungicide program on 9.5 GP, and then bring in the fungicide program on the 9.5 and the fungicide program and the 10. And yes, the fungicide synthetic program with 6 sprays has been fractionally better, but when you put the stats on this, you're not going to get a significant difference between those two. So it really gives us encouragement that actually we can start reducing the number of synthetics within a program and replacing one of those with the Harmonix. So this is about giving us confidence in terms of appreciating how we can use a product before it actually goes out there, and we all have to then learn how to use the products, because this is in a proper program and done in a way that is much more like what you guys will be doing out on the golf course. Now, if we look at the low pressure area, you can see that the scale is completely different. So here we're actually talking of only 7% at the top here, whereas obviously one of the individual axes was actually took you up to 10%. So obviously the differences look bigger because the scale is that much bigger. But again, what we saw in here is that the Harmonix on its own, perhaps as we expected, wouldn't have been quite good enough. What we also found in here was that because we hadn't got any nutrition in the 14-day program, it desperately needed a feed. So we actually did just put a bit of straight nutrition in here, not nutrition that we knew perhaps might have enhancements or reduced disease, of course, just straightforward nutrition. And effectively we got some nice recovery there as actually the turf became more healthy. Following then through, as we said, we've used the guard areas quite extensively. And what we can do here is we can actually say this is one plot to the right hand side and one plot to the left hand side. If I actually put the line on where the guard cell was, we can see some quite interesting things, because certainly 2 or 3 days after application, what was quite clear was that the Harmonix turf defense did definitely have some of that curative activity. And because of its multi-site activity, it's not the same as Iprodion. It won't dry things up quite the same level. But interestingly, the symptoms 2 or 3 days after spraying were very similar to what you used to see when you'd applied something like Iprodion. So I think this could be quite useful in that it's not going to cure everything, but actually if things are beginning to get away from you a little bit, the next bit is to learn how much can we actually get things back on schedule by using the fact that it's multi-site and you're getting that early curative control and definitely visual drying up for the first 2 or 3 days. So that was interesting. If we now look at the plots itself, because pictures always tell 1,000 words, what we can see here is on the left, in December, on the left-hand side, this was the untreated, and this is in the low disease area. This was the Harmonix 2-weekly program with no other inputs in the low area. And then this was, again, the 2-weekly one looking at the plots. If we then go from December through to March, suddenly things look a bit different. These are what the plots looked like in March in terms of the untreated control. This was exactly the same plot that we were looking at a few minutes ago with the 14-day interval. And this was the Harmonix turf defense and the 9.5 GP with the fungicide included.
I think it really highlights Harmonix as a control product, but it's not the full answer. But when we start to build it into a program with fungicides on the next slide with the 2020-30, you can really see that as a part of an IPM, it's got some real potential. You can see that here. So and that middle plot has had no fungicide. Yeah, middle plots have no fungicide either. Yeah, no synthetics.
So I think we've got something here that could be really useful in terms of aiding the sustainability. Obviously, that we know that various things are happening on the legislation, and certainly going forward, we see that Harmonix will play a really useful part.